Hi, my name is Will Kelly. I attend the Rockdale Magnet School for Science and Technology, and my project is on understanding the properties of an event horizon coordinate. So to start off, I know event horizon probably is a foreign term. It means the center point or the center coordinate for a black hole. And the reason I want to understand all these properties, or what it's composed of, what happens to time, what happens to space when we arrive there, is because in the year 1905, Albert Einstein released his theory of special relativity. Now, this changed physics, mathematics, the world of astronomy, really until present day, because within this theory, he had a lot of contradicting thoughts and a lot of contradicting guesses, basically. And the main two were that number one, time has to abide as the same laws of light. And the second part was that event horizon or center coordinate of a black hole is basically has such a strong gravitational pull that nothing known to our universe can escape it. Now, the reason that this becomes really important and really controversial is because, like I said, in that first section, he stated, along with several other people who helped to write it, like Robert C. or Anthony J.G., they all stated that it has to abide by the same rules. Well, if light particles or proton particles can't escape the center of a black hole, though, that means a light particle or time particles can't either. And that means that they have to kind of like bend around larger objects, and it basically puts them into an unorthodox pattern, or causes just the whole theory of time traveling at one pace 24/7 throughout history just not true and impossible. So to prove this for my methodology, everything's going to be a lot different. So obviously this isn't based off of any quantitative data or any numbers, except for one theory that Stephen Hawking wrote that I'll be going over later. Instead, it's mostly qualitative data. It's looking at stuff he said, contradictions he's made, along with other scientists, and comparing them, contradicting them to figure out what's true or what is possible. It's not going to be necessarily concrete evidence that, oh, this is happened or this isn't. More so just the range of it being possible is now true because of the contradictions that these people made. So for the results that I got, like I said, I basically dissected this whole theory into two separate parts. That first one talking about just completely time, space, and then also light, and explaining how those particles move at a similar rate or have to abide. And the way this was proven was actually later. Like I said, this was all just a theory, a guess written by Albert Einstein, but it was proven later when Stephen Hawking put out a mathematical equation to figure out the mass of black holes, or to assume them. Well, after he did that, we noticed that one of the variables is actually substituting for the speed that the center point is rotating, and he calls that center point, but he also uses another term, which is basically the speed of time and how fast time moves. But it's at a variable, it's unknown, so we're able to assume that whatever we fill in for that coordinate can also be filled in for time. And then that second section I was talking about was all about that gravitational pull of the event horizon and how it won't let out time. So looking through those results and looking through just the things that I was able to prove through the contradictions that I made, they're all in my research paper in the results section, I was able to figure out or come to the conclusion of that separately, these statements really don't have a lot of importance. They don't really prove anything except for just irrational situations that might happen, 1 out of a billion. But putting them together, we get the manipulation of time and slowing it into an unorthodox pattern, like I said earlier. And the reason this is so important is because it holds so much opportunities for us to be able to find out new information, such as more carbon dating, such as being able to view other objects in space, galaxies, solar systems, but not having to be behind the 8 ball of space-time light years, right? Which basically means that if I look at something 40 light years away, I can only see 40 light years in the past. I can't see it present. Well, if we're knowing how to manipulate time using that strong gravitational pull and how to slow it, it opens up the possibility for being able to view other objects in space without this hindering. Now, if I were to ever be able to do anything differently, it would definitely just have to do with mainly COVID restrictions. Excuse me. Like I said, this whole project was pretty much just qualitative data and really no quantitative data, because I wasn't able to use a trends map. And trends map is basically mapping out all known objects that we know. NASA does it, SpaceX has a program kind of like it, and it allows us just to get kind of like a sense of direction in space. Allows us to set things kind of as markers, know where we're going, and just act as a coordinate grid over everything. if I had a chance, I would really want to be able to go to a campus like Georgia Tech or UGA that has one of these in their astronomy program, so that I could look closer and actually get some numbers to run, get some tables built, and then I'd be able to make graphs as well. So COVID definitely really cut me down on what I was able to do. Nonetheless, though, the information I figured out was still really important and definitely can change what we got going for us or all of our space programs that we have going.